So we're going to take a look at identifying the graph of parent functions and stating the domain and range of a function based on its graph. A couple typos there in the objectives, sorry about that. So first, these are the main parent functions. We've talked about some of them. So we've already talked about linear a little bit this year, quadratic. So I want you to be able to see what the parent function looks like. X. That's really y equals 1x plus 0. So it's a parent function. It has a slope of 1 and it has a y-intercept at 0. So slope of 1, up 1 over 1, right? So that is the parent function of a line, a linear function. Its domain, when I look to the left and the right, is going forever. So the domain is all real numbers. That's the capital R. You could also just write all real numbers if you prefer. And the range is also going up and down forever, so it's also all real numbers. A quadratic function, the parent function is x squared. And we're going to be diving deeper into this parabola shape, but the vertex is at 0, 0, because when you square 0, you get 0. What happens when you square the number 1? 1 squared is 1. What happens when you square a negative number? So negative 1 squared is also 1. So from the vertex, we've gone over 1 and up 1 in each direction. What happens when you square the number 2? When you square the number 2, you get 1, 2, 3, 4. What happens when you square the number negative 2? Well, you also get 4. So this should look like a round curve-shaped graph called a parabola. Its domain goes forever in each direction, left and right, but its range starts at 0 and then only goes up for y values. So y has to be greater than or equal to 0. A cubic function, x cubed. We haven't seen this one before. What happens when you cube a number? It means you're multiplying a number by itself 3 times, x times x times x. Let's plug in some values. If we plug in 0, 0 times 0 times 0 is still 0, so 0, 0. What happens if we plug in the number 1? 1 times 1 times 1 is still 1. What happens if we cube a negative number? Negative 1 times negative 1 times negative 1. Well, that is going to be negative 1. And it looks like this. It's kind of an S-shaped graph through the origin. When you cube 2, 2 cubed is 8. So it shoots way up here, 2, 8. Negative 2 cubed is negative 8. So it shoots way down there. It goes forever left and right, and it goes forever up and down. So it has both a domain and range of all real numbers. The square root function, the square root of x. So the square root function has a restricted domain. Can I take the square root of a negative number? No. Can I take the square root of 0? Sure. The square root of 0 is 0. Can I take the square root of 1? Yes, the square root of 1 is 1. Can I take the square root of 2? Yes, but 2 is not a perfect square, so you're going to get a number like 1.4. And if you take the square root of 3, you get a number like 1.7. So the next perfect square, if we want to skip over, is all the way at 4. The square root of 4 is 2. So it's kind of a sideways half parabola, the square root function. So its domain starts at 0 and goes forever to the right. So x has to be greater than or equal to 0. Its range starts at 0 and goes forever up. So y is greater than or equal to 0. Look how different these graphs look from each other. So just by looking at a scatter plot, you need to be able to identify which parent function the graph is related to. Is it linear, quadratic, cubic, square root? And then we're going to be shifting these graphs around and flipping them over. So you have to know the basic domain and range so that when this graph gets shifted or flipped, you can figure out the new domain and range. I should have written up here, but domain always goes with x and range always goes with y. It's alphabetical order, x, y, domain, range, in case you forget. So here are a few other functions The exponential function we did look at in our first unit. I'm not going to break down all the key points for you because we're going to spend a whole unit on exponential functions. And we have to pick some kind of a base. So let's say 2 to the x and 1/2 to the x. There's a lot of numbers I could have picked. I could have picked 3 to the x, 4 to the x. I could have picked 1/5 to the x. So this is a number that's growing by multiplying bigger and bigger. This is basically multiplying by something and getting smaller and smaller. So the shape of the graph increasing versus decreasing. And it's a curved shape graph. They both share a y-intercept at 1, and we'll see that more in a later unit. But anything to the 0 power is 1, and this actually has something called an asymptote at y equals 0. So no matter what power you raise this number to, you're just going to get a bigger or smaller number, but you'll never go below and get a negative number. So that affects our range. That's why I want to mention it. So our domain goes forever from side to side, but our range stays strictly above the x-axis. So increasing and decreasing, they have the same domain and the same range. And they both have the same asymptote. And the absolute value function we're going to look at in depth as well this unit, but the basic absolute value function, maybe you remember this function, it means how far away you are from 0. So 0, 0, and then all the values going out have positive outputs. So 1, 1, 2, 2, 3, 3, because 3 is 3 units away from 0. Negative 1, 1, negative 2, 2, negative 3, 3. And I just wanted to show you one other thing in case you like using your calculator to check your work. If you want to graph the absolute value function in the y equals menu, it's under the math key over here, math, and then you want to go to num for number, and then see ABS. So then you've got the absolute value function on your in your y equals menu, so absolute value of x. Just wanted to show you, see it's a smooth V-shaped graph that goes to the origin. And so it's going out forever in both directions, but it's starting at 0 and then it's going up. So the domain is all real numbers, but y has to be greater than or equal to 0. So now you are going to be finishing this last page on your own, and I just wanted to do this last part with you. So let's do 1 and 2 down here. So we're going to define the domain and range for each parent function and define which parent function it is. So for this first one, this is a quadratic. As you can see that it's a parabola. And let's see, its domain is still going side to side forever. So domain, all real numbers. And its range, it's starting at -2 and then it's going upwards. So y has to be greater than or equal to -2. What type of function does this look most like? It looks like a line to me, or a linear function, but it doesn't have an arrow going in both directions. It looks like my x values start here and then they go this direction. So x has to be less than or equal to 2. Looks like my y values start here and then they go up. So y would have to be greater than or equal to -2. I'm above -2 going forever in that direction. So you're going to do this next page kind of the same way. So you're going to look at the graph, decide which of the parent functions, just name the parent function. This one's a quadratic. You can just say quadratic, or you could say x squared. You don't have to come up with this equation of the transformation. Just this is a quadratic. State the domain and range of this new transformed function. And you're going to do the same for each of those 6 examples and send me a picture of that page related to transformations. Please let me know if you have any questions.